And this struck me as completely amazing. But somehow the understanding that one has isn't
The
following.
universe has always whispered its secrets to those who dare to listen, but sometimes it sends a signal so profound it shakes the very foundations of what we believe is real. Imagine a moment when the most advanced machine ever built by human hands, a colossal ring of steel and science buried beneath the earth, catches a fleeting pulse from beyond the stars, a ripple from a place so distant it defies comprehension. This isn't the stuff of dreams or science fiction. This is the story of CERN, the Large Hadron Collider, and a mysterious event that has left the world's greatest minds grappling with questions they can't yet answer. It began with a whisper in the quantum void, a silence where there should have been chaos, a moment when the universe seemed to hold its breath. What did CERN detect in that fleeting instant? Was it a glitch, a cosmic coincidence, or the first echo of something far greater, something that could rewrite our understanding of reality itself? Picture this. Deep beneath the rolling hills of Switzerland, in a tunnel stretching 27 kilometers, scientists are probing the building blocks of existence. They're chasing particles smaller than atoms, smashing them together at nearly the speed of light to unravel the mysteries of the cosmos. But on this day, something unexpected happened. The detectors, designed to capture the frenetic dance of quantum particles, went eerily quiet. Not a crash, not a surge, but a perfect, inexplicable absence, a void where the universe's constant hum should have been. At the same moment, telescopes peering into the depths of space caught a strange pulse, a signal from beyond the observable universe. The timing was too precise to be chance. It was as if the cosmos itself had reached out and touched the Earth, leaving a mark that no one could explain. This moment, this anomaly, wasn't just a blip on a screen. It was a challenge to everything we thought we knew. The Large Hadron Collider, a marvel of human ingenuity, was built to probe the fundamental laws of physics: gravity, electromagnetism, the strong and weak nuclear forces. It's a machine that recreates the conditions of the Big Bang, a place where the rules of the universe are laid bare. Yet, what it captured wasn't a particle or a wave or anything familiar. It was a silence, a bubble of nothingness that appeared in the quantum field, as if the very fabric of reality had been momentarily stilled. Imagine standing in a bustling city square, surrounded by the chaos of voices and footsteps, only to find a perfect circle where no sound, no movement, exists. That's what CERN's detectors recorded: a quantum void, a space where the constant flicker of particles, those tiny sparks that make up everything, simply stopped. Scientists, trained to be skeptical, double-checked their instruments, recalibrated their machines, and pored over the data. But the anomaly persisted, undeniable and precise. What made it even more extraordinary was the connection to the stars. At the exact moment this quantum silence appeared, observatories across the globe, telescopes scanning the heavens for signs of distant galaxies, detected a pulse from deep space. Not a burst of light or a gravitational wave, but something else, something that didn't fit any known category. The synchronicity was uncanny, like two notes played in perfect harmony across unimaginable distances. Could this be a message from the cosmos, a ripple from a realm we've never glimpsed? Or was it something even stranger, a disturbance in the very structure of reality? The scientists at CERN, usually reserved and cautious, found themselves on the edge of wonder. They weren't just looking at numbers on a screen, they were staring into the unknown. The quantum field, that invisible sea of energy that permeates all of space, is never truly still. It's alive with virtual particles, popping in and out of existence in a dance that's been going on since the universe began. But in that fleeting moment, something, or nothing, disrupted that dance. The absence wasn't random. It was structured, almost deliberate, as if the universe had paused to whisper a secret. Researchers began to cross-reference their findings, pulling data from observatories like the Canadian Hydrogen Intensity Mapping Experiment, CHIME, and the Ice Cube Neutrino Observatory in Antarctica. What they found sent a shiver through the scientific community. CHIME, designed to map the universe's hydrogen, had picked up a low-frequency ripple just minutes before CERN's anomaly. Ice cube, buried deep in the Antarctic ice, recorded neutrino interactions that didn't match any known pattern, perfectly aligned with the quantum void. Even LIGO, the gravitational wave detector, hinted at subtle distortions in spacetime that standard algorithms had overlooked. These weren't isolated events. They were pieces of a cosmic puzzle, each one pointing to the same moment, the same mystery. It was as if the universe had sent a signal that rippled through every layer of reality, from the vastness of space to the quantum foam that underpins it all. This wasn't the first time CERN had seen something strange. Back in 2009, when the Large Hadron Collider first roared to life, there were glitches, unexplained flickers in the data that were dismissed as growing pains of a new machine. But now, in light of this new event, those old anomalies took on a new meaning. The patterns were strikingly similar, like echoes of a phenomenon that had been hiding in plain sight. Scientists began to wonder, had they been missing something all along? Was this quantum silence part of a recurring cosmic event, something that had brushed against Earth before, but gone unnoticed? The idea was both thrilling and unsettling. If this was a pattern, it suggested that the universe was doing something we hadn't accounted for, something that didn't fit within the neat boundaries of the standard model of physics. The standard model, that elegant framework that explains how particles and forces interact, has been the bedrock of modern science. It's given us everything from the Higgs boson to the prediction of quarks. But it's not complete. It doesn't account for dark matter, dark energy, or the mysteries of gravity at the quantum level. Could this anomaly be a glimpse of what lies beyond? A hint of a fifth force? A new kind of cosmic messenger that doesn't travel through light or gravity, but through the very fabric of the quantum vacuum? The implications were staggering, and the scientists at CERN knew they were standing at a crossroads. They weren't ready to shout, "Eureka!" Not yet. Science demands rigor, and extraordinary claims require extraordinary evidence. The data segments from that fateful moment were pulled from public logs, not out of secrecy, but to ensure they were thoroughly vetted. Calibration errors, cosmic rays, even the faint hum of Earth's tides could mimic an anomaly if you weren't careful. But the more they tested, the less likely these mundane explanations seemed. The void wasn't just a glitch. It had structure, a geometry that defied simple explanation. It wasn't a random flicker but a precise absence, a shadow cast across the quantum field. Researchers began to run simulations, not for particles or energy, but for nothingness, a void with shape and purpose. As the scientists at CERN stood on the precipice of this cosmic mystery, their minds raced with possibilities that felt like stepping into the unknown. The quantum void they'd detected wasn't just a fleeting curiosity. It was a challenge to the very rules that govern reality. Deep beneath the Earth, in the humming tunnels of the Large Hadron Collider, they began to piece together a story that felt less like science and more like a tale whispered by the stars. The anomaly wasn't just a silence, it was a structured absence, a shadow with shape and intent that seemed to ripple through the quantum field like a stone dropped into a still pond. What made it unforgettable was the way it connected to the cosmos. That pulse from deep space, caught by telescopes and neutrino detectors, wasn't a random signal. It was part of a symphony, a cascade of events that played out across the universe and landed in CERN's detectors with pinpoint precision. The Canadian Hydrogen Intensity Mapping Experiment had logged a low-frequency ripple, a hum from the void that didn't match any known star or galaxy. IceCube, nestled in the frozen depths of Antarctica, captured neutrinos behaving in ways that defied the standard model. Even LIGO, with its laser-sharp precision, hinted at space-time distortions that didn't fit the profile of a gravitational wave. These weren't separate events. They were threads of the same cosmic tapestry, woven together by something that seemed to move through reality itself, bypassing the usual channels of light, gravity, or particles. The researchers, cautious but electrified, began to explore ideas that sounded like they belonged in a science fiction novel. What if this wasn't just a signal, but a disturbance in the quantum substrate, the invisible framework that holds the universe together? They turned to theories that push the boundaries of physics, like emergent spacetime, which suggests that the reality we experience isn't fundamental but arises from a deeper web of quantum connections. Imagine the universe as a vast tapestry, each thread a quantum entanglement linking particles across unimaginable distances. Could this pulse have been a snap in those threads? A shockwave that rippled through the very fabric of existence? The idea of a broken entanglement shockwave started to gain traction, a concept so wild it felt like chasing a ghost. Yet the data supported it. The void wasn't just empty, it had geometry, a structure that suggested something moving through dimensions we can't perceive, leaving only its shadow in our reality. The simulations at CERN, usually reserved for modeling particle collisions, were now crunching numbers for something far stranger, a propagating void, a nothingness with form. The results were uncanny, showing a pattern that matched the detector data down to the smallest detail. It was as if the universe had left a fingerprint, a clue to a phenomenon that didn't play by our rules. What made this moment so gripping was its connection to the past. Those glitches from 2009, dismissed as mere calibration errors, now looked like early whispers of the same phenomenon. Scientists began to wonder if they'd been brushing against this mystery for years, blind to its significance until now. The convergence of data from multiple observatories, each designed to probe a different facet of the universe, made it impossible to dismiss. This wasn't a fluke, it was a pattern, a recurring cosmic event that had finally caught our attention. The implications were dizzying. If this void was indeed a new kind of cosmic messenger, it could mean our universe is more permeable than we ever imagined, open to influences from realms beyond our understanding. Perhaps this was the first glimpse of a fifth force, one that doesn't interact with matter or energy, but with the quantum vacuum itself. The researchers weren't ready to claim victory. They knew the road to truth was paved with skepticism. Every possible explanation, from equipment malfunctions to cosmic ray interference, was being tested. But the more they looked, the more the data pointed to something extraordinary. A phenomenon that didn't just challenge the standard model, but hinted at a reality far stranger and more wondrous than we'd dared to dream. The universe doesn't reveal its secrets easily, but when it does, it's as if it's daring us to rethink everything. As CERN's researchers stood in the shadow of this quantum void, they weren't just chasing data. They were chasing a glimpse of something that might redefine reality. The pulse from beyond the observable universe, that fleeting silence in the quantum field, wasn't just an anomaly. It was a question mark etched into the cosmos. What could cause such a precise, structured absence, a ripple that touched telescopes, neutrino detectors, and the delicate machinery of the Large Hadron Collider all at once? The answer, if there was one, lay in the convergence of these signals, a cosmic chorus that sang of something new. The scientists, with their simulations humming and their skepticism sharpened, began to see this not as an isolated event, but as a window into a deeper truth. The void's geometry, with its hints of higher dimensional mathematics, suggested something that didn't just exist within our universe but intersected with it, like a shadow cast from another realm. It was as if the universe had whispered, "There's more to me than you know," and left us scrambling to decipher its meaning. This wasn't about finding a new particle or force. It was about rethinking the very nature of existence. The idea of a quantum void, a structured nothingness that could propagate across vast distances, challenged everything we thought we understood about the vacuum of space. That vacuum, far from empty, is a bubbling sea of quantum fields, alive with the constant flicker of virtual particles. But this event suggested something could quiet that sea, could still its restless dance, if only for a moment. The connection to deep space added another layer of awe. The pulse, first detected by Keim as a low-frequency hum, seemed to originate from a region near the Cygnus constellation, a place too vast and distant to pinpoint. It wasn't a star, a galaxy, or anything we've cataloged. It was a mystery, a one-time event that flashed and vanished, leaving only its echo in our detectors. The neutrinos at IceCube, the space-time ripples at LIGO, the silence at CERN, they were all pieces of the same puzzle, a multi-messenger event that spanned the classical and quantum worlds. This wasn't just a signal, it was a phenomenon that seemed to rewrite the rules, suggesting that information could travel not through light or gravity, but through the very structure of reality itself. As the scientific community buzzed with cautious excitement, They knew this could be a turning point. The Standard Model, for all its triumphs, has cracks. Dark matter, dark energy, the enigma of quantum gravity. And this anomaly might be a key to unlocking them. The researchers weren't claiming aliens or alternate dimensions, but they couldn't ignore the possibility of a fifth force, one that interacts with the quantum vacuum in ways we've never seen. The simulations, now running day and night, painted a picture of a void that wasn't random but precise, a phenomenon with a shape that hinted at realities beyond our three-dimensional world. The parallels to past anomalies, those long-forgotten glitches from 2009, suggested this wasn't new but unnoticed. A cosmic rhythm we'd been deaf to until now. The scientific method demanded patience. Every mundane explanation had to be ruled out, from cosmic rays to faulty wiring. But the synchronicity across observatories, the precision of the timing, made coincidence seem unlikely. This was something real, something that might force us to expand our understanding of the universe, to see it not as a closed system, but as a place permeable to influences we can't yet fathom. In the end, what lingered wasn't just the data, but the sense of wonder it sparked. This event, this quantum silence, was a reminder that the universe is far stranger than we can imagine, a place where the impossible sometimes leaves its mark. Whether this anomaly leads to a new theory of physics or finds a simpler explanation, it's a call to keep looking, to keep questioning. The cosmos touched our machines, left a fingerprint in the quantum void, and now it's up to us to chase its meaning.